When light hits a solar cell, it generates electrical current. But how exactly does the current respond to different voltages? That's where the IV characteristics curve comes in. The IV curve shows the relationship between current and voltage for a solar cell under a specific level of sunlight. On the graph, current is plotted on the vertical axis and voltage on the horizontal. This curve helps us understand how efficiently a solar cell converts sunlight into electricity. There are a few key points on this curve. First, the short circuit current, or ISC. This is the maximum current the cell can produce when the output terminals are shorted, meaning the voltage is zero. It depends on the intensity of the sunlight. More light means more current. Next, we have the open circuit voltage, or VOC. This is the highest voltage the cell can produce when no current is drawn. It typically ranges between 0.5 and 0.7 volts for silicon cells. Between these 2 points lies the maximum power point, or MPP. At this point, the product of current and voltage, that is, power, is at its peak. This is where solar panels ideally operate. To find how square the IV curve is, we use the fill factor. It's calculated by comparing the maximum power to the product of VOC and ISC. A higher fill factor means better quality and performance. And then there's efficiency, the percentage of sunlight converted into usable electricity. It's determined by the maximum power output divided by the input power from the sun. Several factors affect the shape of the IV curve. Higher sunlight intensity pushes the curve upward, increasing current. But higher temperatures can slightly reduce the voltage, lowering efficiency. Other things like shading, dirt, and cell imperfections can drastically change the curve shape and reduce power output. In summary, the IV curve is a snapshot of how a solar cell performs, a powerful tool for engineers and designers to evaluate and optimize solar energy systems.